Algebras. Welcome to your Chapter 7, Lesson 3 notes. We are going to talk today about factoring trinomials. And yes, the point will be made that your A value equals 1 in this factoring. I'll explain more when I really get into it what that particular piece means. Okay? But for now, I actually want to do a quick warm up with these little puzzles. And these little puzzles are going to kind of warm our brains up to the idea of thinking of the values that will multiply to give us one number or add and subtract to give us another number. And it's the same two numbers that multiply to give us this, but add or subtract to give us that. Okay, that's the first thing we really want to look at. So we're going to use these X's right here as our puzzle, a little puzzle that we're going to do. Okay, I'll read the directions. In each of these diagrams, the two numbers on the sides of the X, so each side here, that's the numbers we're going to find, they multiply together to get the top number, and they add or subtract to get this bottom number. So basically what you want to be thinking of are what are the pairs that multiply together to give us this top number right here. Now 48 is actually a good start only because it gives us a lot of pairs of numbers to work with. Okay, so 48, you kind of think, well, 1 and 48. And I probably didn't leave myself enough room. 2 and 24. And 3 and 16. And 4 and, oh, I definitely didn't leave myself enough room. And 4 and 12. Hold on. I'll leave these guys. 1, 2, 3. And we had 3 and 16. 4 and 12. There we go. A little bit better than 6 and 8, right? Really squeezed them in there. But those are our pairs heading in that multiply together to give me 48, right? Well, now I need to think which of those pairs also adds or subtracts to give me 13. So let's start with on the outside, 1 and 48, right? Will 1 and 48 also add or subtract to give me 13? Well, they add to 49, they subtract to give me 47. So no, that pair won't work. So now try 2 and 24. 2 plus 24 is 26, and 2 minus 24 is 22. No, that's not 13, so they're out. Okay, now how about 3 and 16? They add up to 19, but they subtract to give me 13. So let's think about how that would subtract to give me 13, right? Negative 13. So negative 16 and positive 3. And that's where we get these numbers on the outside. That's the thought process we need today. So let's keep going with that. Think about 36. What are our pairs of factors that multiply together to give us 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And there we go. What can subtract? Also subtract to get 0, right? That's where you're going to get a positive 6 and a negative 6. Just like yesterday with the difference of two perfect squares. Okay? That's where we're getting these values from. So we're thinking about not only what multiplies together to give us the top, but also how do we add or subtract to get the bottom. Okay? Let me do this one down here, number 7, because I'm going to leave a couple of them for you to try with your thought process to get you started. Okay? Number 7, I want you to notice that the difference between all these first 6 and then number 7 is number 7's top number is positive. And notice so far, all of these have been different signs because our top number is negative. We're multiplying to get these negative values. So my two factors have to be different signs, right? We kind of talked about that a little bit back in our difference of two perfect squares lesson 2. So now let's think of the things that multiply together to give me 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And think about all those. Who's going to add to give me 25? It's the only possibility, right? 1 and 24. And if that 25 is positive, it's got to be a positive 1 and a positive 24 that multiply together to give me this positive 24 up here, but also add to give me this 25 down here. Okay, try it again with this 28, right? You got 1 and 28 as factors, 2 and 14 as factors, not 3. How about 4 and 7 as factors? And then that's it. And what of those factors also adds to give me 11, right? 4 and 7. And since a positive 28 and a positive 11, it's positive 4 and positive 7 that will do that. Let me do one more before I let you kind of try on your own. And that one more I'm going to do is number 5. So then I'll have you do 3, 4, 6, and 9 on your own. See if you can do these patterns, right? I'm going to do number 5 because it's interesting, right? Where you've got this negative 42 up here and this negative 1 that we're adding or subtracting to get. Well, again, if your factor number is negative, then you're going to be subtracting to get this add or subtract number, right? So we're subtracting to get this negative 1. Let's think about what multiplies together to give me 42. Of course, 1 and 42, 2 and 21, 3 and 14, 4 and, nope, nothing, not 4, sorry. Not 5, 6, 6 and 7, then we're done. What's the only combo that subtracts to give me 1? And then how can we make that a negative 1 with that combo? Well, it's got to be 6 and 7, right? And if you want this to be negative, then it's got to be a negative 7, but a positive 6. Because see, negative 7 times positive 6 gives me negative 42. But negative 7 plus 6 gives me negative 1. That's the thought process we need to be in to do our factoring today. So I want you right now, we'll do those in red, to stop and pause the video and try 3, 4, 6, and 9 on your own. Okay, and see if you can come up with those factors and the right combo of factors to multiply to get the top, but add or subtract to get that bottom. All right, pause it real quick, then we'll come back and check our answers, okay? Okay, so how'd we do? And I wrote a little note on the side here, right? So check your answers. The red ones are the ones you were doing on your own. Make sure you got those right. And again, the top 6, notice that top number was negative, so we were subtracting to figure out this number. We're subtracting those factors to figure out this number. In the bottom 3, the top number, the factor number, was positive, so we were adding to get this bottom number. And what do you notice with that? If we were subtracting our factors, they had to have different signs. If we were adding our numbers, they had to have the same sign. And yes, I did include the plus sign with my factors so I could be very clear about which signs they had, okay? This is exactly the mental thought process we need to factor our trinomials today. Trinomials, of course, are polynomials with 3 terms. The most likely scenario you're going to run into for these 3 terms, okay, so I'm going to zoom out just a little bit here and do some writing. The most likely scenario you're going to run into for these 3 terms are the combo of ax squared plus bx plus c, okay? This is standard form of our trinomials that we're going to factor. That's the standard form. Put that x squared first, that bx, and then that plus c, that constant at the end. And What that meant in the title when we said a equals 1 is that this value in front of the x squared today, that's just going to be a value of 1. We're not going to get into further than that for the time being, okay? Now, we in chapter 6 took things like this. Okay, I'm going to zoom into that guy because this is really important. Okay, we took things like these binomials, x plus 3 times x plus 5, and we did something called FOIL, where x times x was x squared. Then x times 5 is plus 5x. Then 3 plus x is plus 3x. Then 3 times 5 was plus 15. That x plus 5 and x plus 3, they are like terms that added up to a plus 8x in our middle when we simplified. Simplest form, standard form, right? Well, what that meant was this is the product or answer to multiplication of x plus 3 times x plus 5. That means x plus 3 and x plus 5 are factors of this trinomial. So when we factor a trinomial, we're trying to get what were those two binomials that had FOILed out to give me this simplified result. Okay? That's what we're looking for. That's what we're trying to do. Now, I'm going to walk you through the process. I'm going to use the process as I go, and you'll kind of hear it in how my thoughts are. You'll hear the process happening. But essentially, what we are doing is we are asking ourselves that essential question that we were thinking about when we were doing those X puzzles at the beginning, which is, how am I multiplying to get the end number, but adding or subtracting to get the B term, the middle value? In our X puzzles, of course, that was the bottom number. But now it's going to be, this is the form we look at, and that's then how we factor it back down. Okay, so let me actually factor x squared plus 8x plus 15 using this process, because I know it's right there, and I know you know the answer already because we already did it, right? But I want to show you how I'm getting this, okay? I want to show you where this comes from. First thing, when I know I'm being asked to factor a trinomial, the first thing I do is I make two empty sets of parentheses underneath it. That's going to be my binomials. The second thing I do is I look at the variable being used, typically x, but not always. And I say, well, that variable times itself gave me this x squared. So that means an x times an x is what needs to go in the fronts of my two binomials for that first multiplication in FOIL. Now, I look at the constant. This is the number that you factor. So you think of, okay, 1 and 15 or 3 and 5. Those are the pairs of factors that could multiply together to give me 15. And the reason I start there is because there's going to be less pairs of factors that multiply together to give me 15 than there are combos of numbers that add and subtract to give me 8. So what I've done is I've narrowed down, it's got to be one of these two things that can add up to 8. Now, if your n number is positive, and we're going to get more into sign stuff, you can think you're adding to get that middle number, right? Because when we did that FOIL up here, we had both the same sign. That means they combine by adding those coefficients together. So does 1 and 15 add up to 8? No, it adds up to 16. So that's out. How about 3 plus 5? Yeah, that adds up to 8. So what that tells me is my factors that I'm going to use are 3 and 5. Now, the last thing I need in my binomials are, what are the signs that separate the x and the constant? And in this case, they're going to be the same sign because my n number is positive. And one of the things I'll always tell you and I'll always repeat throughout these videos, is the bigger factor always has the same sign as the middle. So what's bigger, a 5 or a 3? 5. So that means 5 and the middle have to have the same sign. Well, if we're multiplying to get a positive 15, then these two things have to be the same sign at all. That means they're both positive. That's how I can unfoil, right? Undouble distribute to go back to what were my initial two binomials. Okay, above that X puzzle would have looked like this. Sorry that my X was sloppy there. We would have had a plus 15 here and a plus 8 here. And filling in, we would have had the plus 5, plus 3. Now, I want you to notice something. When I wrote my answer this way, doing this, talking out the procedure with you, I typed a different answer here. That I actually didn't do this on purpose, but it's great that I did, because it doesn't matter the order of those two binomials. What matters is getting the right numbers in them with the right signs in them. It's a lot to process, and the sign things are what end up being the most important thing. Okay, but that's why we kind of start with those puzzles to get us in the right mindset. All right, so then we'll just do lots of examples, and I'll go back to the helpful hints after I get started with the examples. And of course, in the examples, I'm just going to be factoring. Okay, so now let's start here. X squared plus 19x plus 34. Trinomial in standard form, and I'm told to factor it. So I immediately start with two empty sets of parentheses. I notice I've got x squared and x in the middle, right? So that means that an x goes in the front of each of these two binomials. And now I look at my end number. That's the term I factor. So I think, okay, what's the stuff that multiplies together to give me 34? And it's either 1 and 34 or 2 and 17. One plus 34 is 35. 1 minus 34 is 33, so that doesn't give me 19, so that's out. 2 plus 17 is 19, right? And since the end term is positive, I know I am actually adding. So let me put those inside my binomials here. And now let's think of the right signs. If your end number is positive, you know that these have to be the same sign. And we already know from me saying it before that the bigger factor always has the same sign as the middle. So what's the bigger factor? 17. What's the sign in the middle term, the B term? It's positive. So 17 has to be positive. But I also know that these two have to be the same sign because my end term is positive. So there you go. There's your answer. Let's try it again. Okay, this time my end term is negative. But again, trinomial, standard form, make your empty sets of parentheses, put your x's in the front because we know that's the variable being used. And now let's think of what multiplies together to give me 15. So 1 and 15, always 1 in itself as factors. And I always use that one first and eliminate that one first. Then, of course, 3 and 5, right? Well, 15 minus 1 is 14. Do I have 14 in the middle? No. By the way, how do I know I have to subtract these two factors? If the end term is negative, I'm subtracting to get this middle term. So 5 minus 3 is 2. I need that 2. Yes, 5 and 3. There it is. Okay, I need that 2 to be negative. Well, let's think about that. Which is bigger, 5 or 3? 5. The bigger factor always has the same sign as the middle for this reason. So 5 has to be negative. Now, if your end term is negative, then these have to be different signs to do that last multiplication in FOIL and get me a negative 15. So this has to be positive. Now, I can write that x plus 3 binomial first and that x plus 5 binomial second. but the signs have to be correct. And they have to be in those binomials. Okay? So those signs have to be correct. That's the commutative property at work. Doesn't matter the way I FOIL, I'll get the same answer, right? The order isn't what's important. It's having those signs with the right number. All right, let's do number 3. What are the factors of 4, right? 1 and 4 and 2 and 2. So my empty sets of parentheses, X's in the front. I need to add up to 5 in the middle. So what's going to do that? 1 and 4. So we put 1 and 4 in here. Now, sign-wise. Okay, your end term is positive. So that means these have the same sign. The bigger factor always has the same sign as the middle, so I know both of these are positive. Let's try another one. Let's try number 7 together. Okay. Oh, what's this number in front of X if there's only a minus in front of X? It's really a -1, right? And because 42 out here is negative, I'm subtracting to get that -1. Okay, you might recall this from the X puzzle in the front, right? We had 1 and 42, and we have 2 and 21, and we have 3 and, what am I thinking, 14, and we had 6 and 7. So which of those combinations of factors is also going to subtract to give me only 1? Well, that's got to be 6 and 7. So my empty sets of parentheses, X is in the front, 6 and 7 in the binomials. Doesn't matter in the front or back, but what does matter is who gets what sign. And who's the bigger factor out of 6 and 7? 7. So 7 has to have the same sign as your B term. That's a minus. That means 6 has to have the opposite sign because they multiply together to give me -42. Okay. All right, I did 4 examples. You're going to do 5. I'm going to have you pause it right here. You work on these ones. See how you do. Okay, work on those ones. See how you do. We're going to do lots of practice with this. Practice makes perfect when it comes to trinomial factoring. Pause it. Give those a shot.